Okay, well, welcome back. And what we're going to do today is we're going to talk about graphs of cosecant, cosecant or cosecant. And also, guess what? And also the secant graph or secant graph. That's a little math humor for you. Well, in any case, what we're going to do is talk about the cosecant graph. Now, in order to figure out the cosecant graph, we first need to consider what is cosecant. Well, cosecant is 1 over sine of x. And if you remember the tangent graphs and cotangent graphs that we talked about before, is that there are some cool things that we can learn about the cosecant graph and the sine graph. So if I graphed the sine graph right here, we know the sine graph, if we put it on our little graph right there, we know that we're going to start here at 0, 0, okay? And then we're going to go at pi over 2. And every pi over 2, we here we have 1. And then we have pi. It's going to be negative, or sorry, 0. And then we have at 3 pi over 2. It's going to be negative 1. And then we have right here 2 pi. And it keeps on going around, round and around and around in a nice, all right, periodic manner. And it goes like that. Now, the thing is that with 1 over sine, when we're figuring this out, is that we know when we divide by 0, we have these things that are called vertical asymptotes. Yes, vertical asymptotes. And so, when you look at the sine graph, and you put it in all the different values that you know, all right, 3 pi over 2, and then 2 pi, you realize we have 0, and then we have 1, and we have 0 again, and then a negative 1 and 0. Well, if you take each one of these values, and let's just do our new graph of cosecant of x, and we'll call that the y2 graph. We'll call that y2. Well, we're going to take 1 over 0. Well, 1 over 0, my friends, is not 0. That actually is undefined. That's a vertical asymptote. So right here, when we look at this graph, is that at this point at 0, it's actually 1 over 0. We're going to have actually a vertical asymptote. So vertical asymptote here at 0. Okay, then we have 1. Well, 1 over 1. 1 over 1 at pi over 2, well, that equals 1. All right, so we have 1 point right there. It's going to be 1. That makes sense. All right, we go over 0 over, well, once again, 1 over 0. Undefined vertical asymptote. So right here, we have our vertical asymptote. Now, on this part, we see that what happens when you approach a vertical asymptote? Well, it either goes up or down. Well, for this cosecant graph, you know in the first quadrant from 0 to pi over 2, we see all the values are positive. So that means we have a positive value. It's going to go up and approach this, all right, if we get close to this vertical asymptote at 0. And then you can see the other, because cosecant is sine, the second quadrant from pi over 2 to pi is also positive, so that's going to go up. And so what we have there is a nice parabolic looking horseshoe going up, and with a min right there at pi over 2, 0. So we have pi over 2 and, pi over 2 and 1. We have a minimum value, okay? And then we go over here and say, okay, we have another value. Well, let's go at pi over 2. Well, we have 1 over negative 1, which is negative 1. And so we have a point right there. Boop. All right. And then we have pi over 2, which is 1 over 0. Once again, is a vertical asymptote undefined. And so it goes la 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 la. Okay, now what happens here? Well, sine in the third quadrant is negative because sine is y. It's going to be negative there, so it's going to go down like that. And then we come over here, and the fourth quadrant, once again, sine is negative, so it's going to go down like that. So now we have another horseshoe, another parabolic-looking object right there. But actually, this one is a max. All right, a max over at 3 pi over 2 and negative 1. I know it doesn't seem like it should be a max there, but it is. And so what we have for a range, you see that all the values for y are everything greater than or equal to 1. Or you see this huge gap there, all right, because we have nothing in the middle because everything is either going up from 1 and up or from negative 1 down. And so we're going to have everything less than or equal to negative 1. The domain here is, well, we look at our vertical asymptotes, and you realize the vertical asymptotes are just like the cotangent vertical asymptotes, because that's where a sine is at. So for every pi unit, so when x equals n pi, that's where we have a vertical asymptote, because that is when sine equals 0. When sine equals 0, you get undefined. So our domain is all reals except x can't equal pi or any multiple of pi. So that's the domain of the cosecant graph. Our period, well, if we continue on, all right, we can go over here and say, okay, we'll have 5 pi over 2, and that's going to be, guess what? It's going to be 1 again, and it's going to go up like that, and then we can go to 7 pi over 2, and you know it's going to be a vertical asymptote, blah, 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 and it keeps going like that, and it keeps on going on and 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 on. All right, oops, that'd be 6 pi over 2, which would be 3 pi. I apologize for that. All right, maybe you caught that. So what is the period? Well, the period, unlike tangent and cotangent, this is just like sine. The period where it keeps on repeating is going to be every 2 pi's. All right, and that's the period that we have for cosecant. So the key thing when you're doing here is that when you're looking at the cosecant, change it into sine cosine, and think about the sine and cosine graph. Do the reciprocal of the y values, and that can indicate where your vertical asymptotes are, and also where your max and mins are. Remember that they never cross, well, I don't say they never cross x-axis unless it's moved, okay? Because we have this line of symmetry right there, or not a line of oscillation necessarily, is always at 0. And so it doesn't never crosses this line, all right? It goes up or goes down with a gap in between, okay? Well, the same thing can be said for our secant graph, all right? Our secant graph, because secant is 1 over cosine of x. So if we think about the cosine function, all right, it's very similar to the sine function. We start at 0, and we have pi over 2, and then we have pi, then 3 pi over 2, and then 2 pi. And we know this one's going to start at 1, then 0, then -1, then 0, and then 1 again, okay? Now, just like that, when we have our cosine graph, and as we graph this out, okay, we really have one there. That's going to be pi over 2, and every multiple of that, so I'm just going to go like this. All right, and I think you can figure it out now. Just save a little time. All right, and we have this graph going up like so, and then it keeps on going, and then it goes down right there, and the same thing over here, -pi over 2, and it goes like that. Okay, but what you realize is that when you graph this one, and we'll call this y2, all right, where it's going to be secant of x, all right there, is that our x's are the same, but our y values are going to be the reciprocal of our y values here. So 1 over 1 is 1, okay? And so I'm going to make this in green, okay? And so that's going to be 1. We come over here, we have 1 over 0. Well, we know 1 over 0 does not exist. That's a vertical asymptote. So it's going to be la 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 la. Okay? This is going to be 1 over -1, which is -1. And then you have 1 over 0, which is undefined, vertical asymptote. Okay, then you have 1 over 1, which is 1. All right, and you have another point right there. And then you can see where you have another one right there. And then right there at -pi over 2, you have another vertical asymptote. So when you graph this, you can see that, okay, when is cosine positive? Well, in the 4th quadrant, which is located there, and in the 1st quadrant, which is located right there. So don't pass the vertical asymptotes. Right here in the 2nd quadrant, it is negative. And also in the 3rd quadrant right there, which is negative. And we can keep on going onward and onward, and it keeps on repeating. But you realize that once again, you have a, all right, domain, all right, domain or vertical asymptotes. Well, it appears that every multiple, okay, pi over 2 plus pi, okay, we have plus or minus and pi, all right, we have a vertical asymptote. So our domain is, once again, all reals, x cannot equal the vertical asymptote. Okay? The range is just like the range of the cosecant graph, everything greater than 1 or y values less than or equal to -1. We have a min a little bit different. A min right here at 0 and 1, and then you have some other ones, and they keep on going right there. And you can see you have a max right there at, okay, pi and then -1. And then our period, just like cosecant, is 2 pi. That's our period, because it repeats every 2 pi units. And so looking at this graph, all right, you can see that secant and cosecant are similar, just like sine and cosine are similar, except they're just simply a transformation of each other. Okay? If you start right here with secant, you realize that cosecant is shifted to the right, just simply pi over 2 units. All right? If you start over here at cosecant, all right, you realize that secant is just simply a shift to the left, pi over 2 units. So depending on how you look at it, we have that right there. All right. Well, those are the two graphs of cosecant and secant. Hope this helps you out, and we're going to do some transformation in the next video.